Hi everyone, my name is Ezgi. Today I would like to talk to you about thermal comfort assessment of hospital building via objective and subjective measurements. My presentation is in 6 parts. Firstly, I'm going to look at the aim of the study. Following, I will show you information of thermal comfort. Next, case study and then methodology. Next, findings, and finally, we will look at conclusions. Okay, let's start with aim of the study. This study aims at assessing the compliance of indoor environmental conditions with ASHRAE Standards 525 and ISO 7730 thermal comfort standards, comparing the predicted and actual thermal perception of occupants. Information of thermal comfort. Thermal comfort is among the most important factors within the built environment. Thermal comfort can be defined as the state in which the occupants feel physically and mentally comfortable within the existing indoor environmental conditions. Also, thermal comfort significantly affects satisfaction, productivity, and well-being of occupants in buildings. Parameters affecting thermal comfort are divided into two as environmental factors and personal factors. Environmental factors are indoor air temperature, relative humidity, air velocity, mean radiant temperature. Personal factors, clothing insulation, and metabolic rate. So let's move on to case study. In this study, a hospital building located in Izmir, Turkey was chosen as a test site. This study was carried out on February 27, 2020, which is the heating season. Objective and subjective measurements were conducted simultaneously in various healthcare areas. Indoor air temperature, mean radiant temperature, relative humidity, air velocity, and carbon dioxide levels were measured at 1.1 meter above ground level, and the values were recorded instantly. A survey was designed based on the ASHRAE Standards 525 in order to understand occupants' perception about the built environment. A total of 35 surveys were included in the analysis. The majority of occupants were between 25 and 34 years old. Moreover, most of the participants were nurses, and the participation rate was higher for females. So we've come to methodology. Assessment of objective measurements and PMV PPD indices according to thermal comfort standards. These standards are ASHRAE and ISO. Comparison of PMV and AMV indices with analysis. T-test was applied for comparison. Calculation of PMV and PPD indices. The CBE thermal comfort tool was used to calculate the PMV and PPD indices. Average values of operative temperature, air velocity, relative humidity, metabolic rate, and clothing level for each measurement entered into the program. And as a result, a single PMV and PPD value for each test was obtained from the program. So let's move on to the findings. Assessment of indoor environmental conditions. As can be seen from the table, there are 15 various healthcare areas, and reference values are shown in the table for each parameters. None of the operative and indoor air temperature measurements were within the recommended values. All relative humidity ratios were within the recommended values according to both standards. Air velocity measurements were within the recommended values in all healthcare areas. Assessment of carbon dioxide levels. As can be seen from the table, the percentage of 53.33 of the carbon dioxide measurements were within the recommended values. assessment of PMV and PPD indices. As can be seen from the table, none of the PMV and PPD values are indicated are thermal in nature indoor environment. And thus, it can be concluded that indoor environmental conditions were not satisfactory for the occupants. Comparison of PMV and AMV indices. As can be seen from the table, the PMV values suggested that all healthcare areas were thermally acceptable. On the other hand, the results of the survey shows that only percentage of 53.33 of healthcare areas were thermally acceptable by the occupants. First, Kolmogorov-Smirnov test and Lewin's homogeneity test were conducted to determine the applicable statistical test for comparing the mean values of the PMV and AMV. Results are shown on the slides. The results show that the values are normally distributed and the dataset of PMV and AMV values are not homogeneous. So, t-test is conducted to understand PMV and AMV values. T-tests show that the difference between the mean of AMV values and the mean of PMV values are not statistically significant. In other words, the standards were not able to predict the actual thermal sensation of occupants. Finally, let's move on to conclusion. The measured indoor air temperature values did not comply with the standards. The measured relative humidity values were within the recommended ranges specified in the standards. The measured air velocity values were below the maximum values specified in the ISO 7730 standard. Percentage of 53.33 of the carbon dioxide measurements are below the maximum allowable level specified in the ASHRAE Standard 62.1. The difference between the values of PMV and AMV is not statistically significant. Thank you for listening.